Hello everyone, welcome to my presentation on Bridging the Gap, Efficient Cross-Lingual NER in Low-Resource Financial Domains. I am Sunisht Kumar, a software engineer with a keen interest in NLP and low-resource languages. This work was done in collaboration with Genify, a fintech company based in Dubai. Today, I will share our efforts in developing an efficient cross-lingual named entity recognition model for financial transaction data. Our approaches leverages knowledge distillation and consistency training to tackle the challenges associated with low-resource languages. Let's dive in. The next slide. Here's the outline of my presentation. I will be covering the following topics. Let's start with the motivation first. In the context of developing accurate cross-lingual NER models, the importance of data cannot be overstated. Let's use an analogy to understand the significance of labeled and unlabeled data in NER training process. Labeled data is like sort of gold, well stacked, polished, is meticulously annotated, making it a very valuable and reliable resource for training NER models. And on the other hand, unlabeled data is just like rocks. It is unprocessed and scattered. While rocks do have potential value, extracting that value from it requires effort, and this disparity is evident in NLP landscape. The images I'm showing here aren't to scale. Annotated data is a tiny fraction compared to the abundance of unlabeled data. This disparity becomes even clearer when you look at the world map showing NLP solutions available for different languages. Despite having large populations, many languages lack adequate NLP resources, especially in domains like the finances. In financial domain, named entity recognition plays a critical role in extracting valuable insights from financial texts. Whether it's identifying merchants, amounts, or currencies, accurate NER is crucial for various NLP applications in finance, including sentiment analysis, risk assessment, and investment recommendation systems. The motivation behind our research stems from the experimental growth of digital content in financial services, which often involves multiple languages. The companies operating in numerous markets face the challenge of analyzing customer feedback, social media posts, and other unstructured data in multiple languages, and accurately identifying named entities in these languages can help the companies extract valuable insights, identify the trends, and make informed business decisions. Developing accurate cross-lingual NER models, however, presents significant challenges. Low-resource languages often lack sufficient labeled data, making it difficult to train effective models. Additionally, capturing cross-lingual variations and nuances adds to the complexity. Our motivation behind this research is to address these challenges by developing an efficient and effective cross-lingual NER model for financial transaction data. Now let's dive into the problem definition. NER involves identifying entities like organization, currency in text. We formulate the cross-lingual NER task as follows. We have an input text sequence represented by X, where N is the length of sequence, and each token Xi is associated with the label Yi, representing its NER tag. The set of possible NER tags is denoted by Y set, where K is the total number of entity types. Our objective is to learn a model M that can accurately predict the NER tag Yi for an unseen given input Xi in different language. Now let's revisit the problem definition with a simple example. Here, entities like organization and monetary value are highlighted to illustrate the task. We created a dataset containing SMS data in both English and Arabic, carrying semi-structured banking transaction information with 1,730 samples in English language and 30 samples in Arabic. The dataset is sourced from Egypt. Both language datasets were pre-processed to hide sensitive information and converted to the standard IOB format for NER before training. Additionally, to complement our in-house dataset, we also use the Wiki-ANN dataset for evaluation purposes. One of the key objectives of our experiments was to develop a cross-lingual NER model that achieves high performance while maintaining a manageable model size. And traditional large language models, while powerful, can be computationally expensive and memory intensive, limiting their practicality in real world applications. To address this challenge, we leveraged a technique of knowledge distillation. By transferring knowledge from a large pre-trained language model to a smaller model, the student, we were able to reduce the model size significantly while retaining performance. The teacher model is a pre-trained XLM Roberta we have used on English data. It serves as the source of rich knowledge. We distill this knowledge into a smaller DistilBERT model. This process allowed the student model to benefit from the representations learned by the teacher, leading to a more compact yet powerful model. For consistency training, we generated augmented versions of the target language data using back translation, RAND augment, and TF-IDF word replacement. The Arabic language dataset is used unlabeled for consistency loss and labeled for the supervised loss. In the knowledge distillation loss, we use a weighted combination of supervised cross-entropy loss and the KL divergence loss between the softened probability distributions between the teacher model and the student model. While in the consistency training loss, we also use a weighted combination of supervised cross-entropy loss and KL divergence loss, but this time we compare the softmax probabilities between the augmented and original data. During our experiments, we found that setting the alpha value to 0.8 yielded the best results for our consistency training approach. At this value, our cross-lingual NER model achieved the most desirable learning behavior, effectively generalizing to the low resource target language while leveraging knowledge distillation and consistency training to deliver superior performance. Now let's discuss the results of our experiments. In table 1 for the English dataset, our model achieved an F-score of 0.9768 and accuracy of 0.9782. Although the teacher and student models exhibited higher F1 scores, our model's competitive performance is noteworthy, especially given its smaller size compared to the teacher model. On Arabic dataset, our model significantly outperformed the teacher and student models, achieving an F1 score of 0.6540 and an accuracy of 0.7407. Furthermore, our model performed better than the naive benchmark model with an F1 score of 0.6065. Now, the table 2 shows that while the teacher model achieved a recall of 0.62, the KD plus CT model demonstrated notably high precision, reaching 0.87. This emphasis on precision holds particularly significance in domains such as finance and related fields, where accurate identification of entities is crucial. Table 3 shows the experiments on Wiki-ANN benchmark dataset. Our results on Wiki-ANN dataset are promising and align with our main argument. Utilizing a few samples of target language in semi-supervised learning outperforms unsupervised approaches, even when dealing with smaller datasets. Here we tested against the benchmark models CON-NER and MST. These results demonstrate the remarkable cross-lingual generalization capabilities of a model, even with the limited label data in the target language. To summarize, we leveraged knowledge distillation and consistency training to enhance cross-lingual NER for semi-structured financial text. And this approach is both efficient and effective, requiring only a few labeled examples in the target language and low computational resource. Thank you for your attention.